Okay, welcome back. The next gas law we're going to talk about is Charles's law. Okay, there's the mathematical formula for Charles's law. You can see it's a little bit different. I'm not going to explain the math. I want you to understand the concept. So Charles's law says at a constant pressure. Now this is key here. Charles' law, pressure has to be constant during the experiment that we're going to take you into the kitchen and do. All right, so pressure is going to be constant, and that means temperature and volume are directly related. Okay, so when pressure is constant, if temperature goes up, volume will go up, and vice versa. When temperature goes down, volume goes down. Let's watch this experiment. Hi everyone, welcome back to my kitchen where we're going to continue with gas law experiments. Okay, we are about to prove Charles's law. So Charles's law states that when pressure is constant, all right, so right here in my kitchen, barometric pressure is going to be constant. It's not going to change in the next couple of minutes. So it says when barometric pressure, when pressure is constant, volume and temperature are directly related. So as you can see right here, we have a saucepan full of pretty much boiling water, super hot, right? So increased temperature here and a decreased temperature here where we have an ice bath where that water is really cold. We also have an empty bottle of water, all right, with the balloon on the top. So this bottle of water, when it had water in it, it contained 591 mLs of water. So without the water, we can assume there's 591 mLs of air in that bottle, okay? So that's our volume. And so what Charles's law says now is if I put this bottle over that hot water, that volume is going to expand. The volume inside the bottle will expand, and as it expands, that balloon should inflate. So let's see if that's true. Okay, see I'm holding it over the bottle of water. Oh, look at that go. I'm holding it right on the surface of water. And do you see? Do you see that volume of gas in that bottle is expanding? And as it expands, it starts inflating the balloon. So increased temperature equals increased volume. All right, we've already proven that worked. But just in case you want to see it in the opposite direction, because my hand's getting hot like this, I'm going to now take this bottle of water, or empty bottle of water, and I'm going to plunge it into the ice bath. So we're decreasing temperature. We should see a decrease in the volume, so that balloon should deflate. Let's see if that's true. See, it's shrinking. So we're decreasing temperature and the volume in there decreased also, as evident by the balloon collapsing. So there you go, Gay-Lussac at its finest. Come back and we'll do more gas laws. See you soon. Okay, did you watch the experiment with the boiling water and the ice bath and the balloon on a water bottle? If you did, you will realize that as the temperature of the gas increased, when we put that bottle of water into the boiling water or the really hot water, that balloon expanded. The volume inside the bottle increased and expanded the balloon. And then when we took that same bottle, empty bottle of water, and we put it in an ice bath, we decreased pressure and volume shrunk, which caused the balloon to decrease, okay? And remember, pressure remained constant during that. Barometric pressure did not change. So a clinical example of this is when we measure lung volumes in the pulmonary function lab. Okay, a lot of times there is something called a vital capacity maneuver that's done in the pulmonary function lab. So we take a great big deep breath in, and we have a particular volume of gas in our lungs. But the volume of the gas in our lungs is at 98.6 degrees, right? Normal body temperature. But we exhale that gas into a spirometer that is at room temperature. And the spirometer is going to measure the gas coming out of our chest into the spirometer. We've gone from a 98.6 environment to an environment that is, let's say, if the room is 70 degrees. So we've decreased temperature moving from the lung into the spirometer. So volume's going to shrink, All right, so we call this body temperature pressure saturated. That's the volume of the gas, the measurement of the gas while it's in the body at body temperature. And then that volume of the gas when it's in the spirometer, as the spirometer measures, is called ambient temperature. That's the ambient temperature of the room. And there has to be a conversion factor because gas will shrink as we move from body temperature to ambient temperature, and it's all because of Charles's law. All right, stay tuned and we'll go to the next one.